All right, I thought I'd go over generics in detail, just because I know that's something that's kind of confusing. That's not really gone over a lot in 380. It's gone over a little bit, but I feel like they don't really go in depth enough with that, and they're pretty helpful. Um, Also, I know some of you didn't take 380. I think I don't know who. Off the top of my head, but so basically, what a generic is it's a way to put a to create a well, okay, there's two versions of generics. There's functions and there's classes. So you know a class is a generic, and you can have a function that's a generic. And they're each a little different, but the same idea. So basically, it's a way of creating a function that instead of taking a specific variable, so say you make like private void add, and you do like int a, int b, and then um, you're inputting to this like adding function two integers, and you can only put an integer. So if I were to like go down here and just do let's do private void. Actually, I guess I just do it inside of itself because I'm not going to run it. So if I were to go into this, if I try to run add, if I can put ints, it works fine. I mean, things just recursively loop and crash, but I can't do that. But if I try to put in 1f, I think it'll take flows. I think I can. Nope, I can't. It'll have this error because a different type. So it's basically you have to input the specific type as an integer. You obviously can't, but input like say a character or a string, or else it just won't take it. Actually, it's taking a character for some reason. I guess I can convert characters implicitly. It's kind of funny. I didn't know that. I mean, technically anything can be converted to an integer, because it's just. I mean, anything can technically be converted to anything in a sense, but any binary any chunk of binary of any length can be converted to a number just because of how binary counting works. But I guess it implicitly can do it for. I know that's kind of interesting. Like there was like character codes that are numbers or well they're binary and they also have numbers because they're binary. Anyway, but what a generic would look like is it would be private void you do t sort of in these little triangle braces, and then I don't really think add would make sense, but any of this, and then you can put in input um, t. Oh, that's the wrong way around. Heck. Sorry, the t goes after the name, and then what you can do is you can do t, and then you can name it just variable, and this t can be anything. So now if I want to run add, I can do add. Obviously, it's polymorphic now because we have both of these. You can have as many functions of the same name as you want, as long as they each take in different parameters. That's referred to as polymorphism. Yes, polymorphism. I'm gonna double check that. I'm pretty sure that's what it's called. Uh, C sharp. I think it's in all languages too, but polymorphism, polymorphic, polymorphism. I think that's what that means. Double check that I'm using that word right. Oh, that's for inheritance. What is it called? I think this has to do with family system. Oh yeah, no, so it's inheritance. C sharp when two functions named the same but have different parameters. There's a term for it. Overloading. Ah, okay. Overloading is a term. Polymorphism is inheritance. Has to do with inheritance. So you can overload it. I feel like I've heard it used the other way though. Anyway, so I can input, 1, which would be this one up here. But if I want to actually run this one, I can actually input literally anything. So I can put 1 and it'll work. But because it's t, I can also input a string and it'll take it. I can input character, and it'll take it. I can input, also took it up there though, so I guess it's not that impressive. I can input um, new game object. So I can put game object into this function. I can input a vector three. You input literally anything. Um, vector three. No, doesn't have to be new vector three. I can do vector three dot one. There you go. So anything can be inputted into this into a thing like this. Um, that's the basic idea. Obviously, this then creates the issue of like, okay, so we have a variable, and because this variable can be literally anything, like right. So say go back up here, ints. We can do a plus b, and we can make this return, an int, and then we can just return. Like we can do stuff like this. We obviously that's two numbers, you add numbers together. But when you have just like a variable, it could be literally anything. So I do variable plus variable. If I just try to add it to itself, it'll give me an error because like it can't do that. You can't use operators with these usually. And the reason why is because this could be literally anything. You really can't do a whole lot with a generic that is just T. That is like this. What you can do though is you can add constraints, which will basically say, so here's an example. You do where T, which refers to this, what this type can be. Let's say we want to make it have to be you do a lot. You make it have to be a class, and then it'll have to be a class. So what this means is we know it's nullable. And so what this means is now if we do variable dot nullable or variable dot equals null, we can do that. Variable, we do like an if statement. If equals null, it'll ask that. If we get rid of this, we can't because it's like, I don't know, it's a class. At least it should. I think. Because an int can't be null. Interesting. It's not doing that. Maybe the checking isn't. Maybe I had to update. Here you go. Variable equals null. That's an error. Now if we do go back to where struct class, and now wait, no, that's right. Now I'll take it, yeah. So without this, with this it can be null. Without this, it will get mad at you. And that's kind of thing with constraints. So constraints allow you to say, oh, it's this type of thing, which allows you to do stuff with it. So you kind of need a constraint usually to do much with it. Sometimes you don't. It depends what you're doing a little bit. For example, like if I was like, if I were to like have an array, right? Like if I were to make a function that were to like resize an array, like do something like a private void resize array t t. So do arrays of these. So t array array, because I'm working with like this data as an array. I wouldn't really need to care what it is. Like it could be a class, it could be a string, it could be literally anything. Because what I'd be trying to do is I'd be trying to resize array. So I just do like new t array or like t array temp array equals new t array dot length dot plus one, so I get one longer. Then you would loop through and you would just go. You do this. And then you have that. And then tempo, or actually, I don't want this. Temp array. I don't spell array right, but array I equals array I. And then we need to add to the last slot, so we copied it over, and then we do temp array dot length. It's one to get the last slot equals. So now I need to fill in the last slot. And this is where it gets kind of tricky because obviously we don't know if it's int. Like if it's an int, we could just be like, I don't know, 0. Or if it was a game object, we'd be like, new game object. We don't know what it is, but you can do something. Use a keyword called default. and that'll just put it to whatever the default value is, and that can vary. Depends what it is. If it's struct, I want to say it runs like the default constructor, like the empty constructor or something. I don't really know exactly. I think it can make it null if it's a nullable type. So say you put in like a game object, it might not actually. It might just fill it in with a null. We'll give you an arrow to just make that null, as long as you don't try to read from it immediately. But yes, yeah, default's a keyword for working with these. And then you would, whatever you would do, array. In this case, you're resizing an array, so you don't really need to care what's in the array. You're just like, so this would just be a generic function that could work for literally like anything. So you can make like an int array. I think the default for an int is 0. Int array ints equals new int array, make it 0, so make it empty. And then you could do private void t test. A little function down here, just write in. You can do ints resize array. There you go, and that would make it one longer. But then you can also do, you can make game object array. Yeah, looks good. And then you can do same thing. Game object. What do? Resize array. There you go. And it'll also work for that. So it'll do the same thing, just it doesn't matter type. This is really nice because you don't want to like say you have like an array of something like this, and of like ints, and you have an array of game objects. You probably don't want to have to write a function for resizing a game object array, then another one for writing or resizing int array. You don't want to have to like keep doing that. So you can just make one generic one or a couple generic ones for like working with arrays, and you never have to make another one again. So it saves a lot of time. It can be really helpful, that kind of stuff. What you'll see too with when you format it is like you see how this one has this little triangle bracket and then ints, and this one doesn't. That's just because of how it filled out. You can actually do game object. I'll do the same thing, and you can take security. So what's happening is when you call these functions, it wants you to kind of format it like this, kind of in a call form, where you have like, you put the function name, and then in triangle brackets you put the type, and then you put the parameters in. Though usually it can like the compiler and stuff can figure it out if you don't, because it can be like, oh, you put in an array of game objects, so you probably want a game object. Like it can kind of read it backwards too, so you don't need to. So yeah, so if I do try to if I do put the triangle tags for game objects and then put in ints, it will probably get mad at me. That'll also make you get mad at me, ints, because it's like, oh, you want game objects, but you put in that thing. But this will actually take it now because it's just gonna assume I want ints. So yeah, so usually you see triangle brackets, but usually you can figure it out. So either's fine, either works. Though it is nice to have these sometimes, even if it is kind of like you don't need to be like, I'll tell you can simplify it. I'll be like, oh, okay, and I'll just get rid of it. But it can be nice for readability. Because maybe like you name your variables weird. You're like, oh wait, what is this? But if you just have like ints, it's like and this is kind of similar. If you like make a game object, right? Let's do game object. Geo was new. I guess I don't really need to do this because I'm not gonna actually run this, but you can do when you do game object dot add component, you do these brackets, right? These triangle brackets, and you would add, say, I don't know, rigid body, and then this. It's the same thing, right? It's basically a generic function, but it has no parameters. So like I could do a very similar thing up here of like, right, private void add component, and then t, and then just empty function. There you go. It's the exact same. Like you call it the same way. You would do obviously it's not gonna like be part of game object, but it would just be add component. Do that, and then you just input. I could also just input rigid body because it can take anything. Yeah, so it's exactly what it is. It's a generic function that takes in a type. I would assume this type here is constrained to whatever rigid body is in the engine. I think it's a component. Here, let's see. So it's constrained to that. So where t component, and there you go. It's literally does this exact thing. I'm pretty sure. I think we can actually check if we want. Obviously, it does actual code in here. It's not just an empty function, but pretty sure. Does some weird stuff. But I'm pretty sure functionally. Oh yeah. You can see it has like a generic t It also returns it out so you can get it easy. But yeah, same thing. And then it does return add component type. If it is whatever this add component is, all the chain. But yeah, basically it's structured like that. But there's some other stuff it's doing. Has some internal system. But on the surface, like in terms of how you call it, that's exactly what it's doing. It just also returns T. So, you just add T. No, I don't know why I typed return. Just put it there. There we go. Private T. Why is it mad at me? Oh, because I didn't turn T. I mean, I assume you'd get in some way. Just do. Does it take new? Let's see. Does not. I don't know how the systems work. Yeah, but that's basically how it works. It would add it and then it would return what it adds. So basically, this is how it's that's how it's formatted. So you're adding components as a generic. Yeah, anytime you see these triangle braces, that means it's generic, even if they're optional. So that's how they work with functions. Classes are the same thing, basically. Delete these. There's some better kind of examples I'll go over after I go over classes and show a use case, or at least some more detailed examples. Where the hell did this come from? Check how long I've been going. Oh, wow. I meander a lot. So for class, it would be public. It's very similar. Class, generic demo. And then, I'm remember how you write classes like that. Right. And then if you want to add a generic, you would just do that. And what this allows you to do, in the same way that having a generic in I should get the functions in. A function allows you to use the parameters of t. You can use like variables of t. So I could do t variable, t variable. So like that's one. I can do another t variable two, and so on. Then I can like write functions with them. So public void and whatever. I can do variable. Once again, because they're not really constrained, I can't do much with them. But I can get type. That's something you can do for anything. So you can work with them, and in the same way you can constrain them for functions and constrain them. Up here you do where t is class. You can do enum. That's another way you can do enum. You can do these in the system namespace because the enum class. This is a little different than like lowercase enum. It doesn't take this, but if you do uppercase, it's fine because you can constrain to a specific class and inheritance of that class. Which is pretty cool to do. It opens up a lot of things. But to do this with enums, you need to have a system. But now that's t's enum. It means these are both going to be enums. So let's just do like enum dot get values variable. Oh, type of. Actually, I don't even need to have these variables. Let's just by type. Type of t. Whatever. Yeah, so I need to solve that. But yeah, so you plug it in basically the same way, and then you can just make variables of those types, and you can do whatever you want to do in your class, but you just have this sort of type that could be a bunch of different things. And it can be, type you make, such as a class. It can also be enums. It can be, the big one. There is a list of them here in the Microsoft documentation of C#, of the ones they have built in, where it's like struct, class, not null, default, unmanaged, new, which makes sure like you can make a new class. Like, is actually a really useful one because if you do class, you often do new because new enforces the class to have a parameterless constructor, which would be really helpful if you need to like make a new class. Like say you need to fill something out in an array, like the new slot, that would help. Base classes is where it's just saying you can do your own classes. You also do base class. which is some specific thing. I haven't really used this yet. You can do interfaces, so you can make it of a certain interface and also interface, and whatever U does, whatever the hell U does. Um, yeah, so that's kind of the idea. Enum would definitely be an example of this one because it is a base class. It's not one that you make, but it's one that just comes from system. It's a really helpful one that lets you get like all the contents of an enum as opposed to just like looking at one item. Should be really helpful for like certain things. Um, yeah. So another thing to go over is you can actually have multiple t's. So right now it's like, oh, we have one t, but you can actually do, t1, t2, t3, t4. I don't know what the limit is. I think it might be 12, but maybe it's 8. It's a lot. And now you have 5 of them. Oh, so these can be named literally anything. So you can do A, B, C. You just can't name the same thing as another one, basically. So we have 4. And then you just have to update this. So this is where A is enum. And you can actually constrain different letters or different, oh god, I'm blinking. Different ones of these to different things. It's kind of formatted weird. I think you just start doing another where. So where B would be, let's say this is class. And say you want to do 2, because you actually do 2 constraints new. So this is, B has to be a class that has an empty constructor, or like a parameterless constructor. And then you just do where C, this just has to have a new constructor. So this could also be, this would also kind of, I think structs would also count in this. So this could be a struct or a class. And then you can have another one where D is, I don't know, it's just struct. And it looks kind of not great. I kind of wish there was like some sort of like, like between each one you had to do like this or something, but also that'd be annoying to remember. It just looks kind of weird. But yeah, so you can constrain them each different ones. You can add a bunch of them. And yeah, they can all do different things. Same goes for functions. You can add as many as you want to a function as well. Well, I think there's a limit. Let's see. Limit to generic type in C#. Like there's got to be like a count. I feel like it's like 11 or 12. I think it's just thinking of 16 apparently. Or at least in newer. Well, how old is this? 13 years. Okay, this is very old. So I need to be even more now. Oh, this is only for in parameters though. Yeah, you can do a lot. I think it's 12. I think it's 12 because that's the most amount of parameters you can put in the things, or maybe it's 16. I don't know. It's one of those two. I haven't really stress tested that, but yeah, so you can do different things. So the big thing with these are use cases can be kind of it's weird to think of these in terms of use cases. Like in 380, they're taught as to use them as a singleton. So you would do like, public class singleton, and then you put in a generic or something. And it's like type where T is where type. Oh, that's right. Type is a class, and then you do probably did something wrong here. Yeah, I need that, and then you do like your singleton implementation. So you can just create a singleton of like anything you want. Singleton. Yeah, I think it's the way it's taught 3D. That's all they really go over. Maybe they show a function or two, but it's I feel like this is this is a use case. It's not the best use case. It is a use case. It's just like they can do so much cooler things. Um, and also I feel like this encourages using a lot of singletons because they just make that way easier to do, which is not good. But so I'm gonna show sort of a couple quick, or I'm gonna show a use case for each of the type of the class versus a function. So for a class, I think my idea was say you have like have like a JRPG or something. You have some sort of RPG or some sort of game. I mean, Entoworks works too, where you have like an inventory, right? And you have like you have like say swords and shields and like armor, right? You have those three things, and you want to have like sections in your inventory of like, oh, this is where your armor is, this is where your swords are, this is where your shields are, or whatever. And basically, each of these sections are going to functionally have the same, actions. You're going to be able to like move them around. You're going to be able to, and you're going to be able to equip them, unequip them. Like all of them have the same functionality, and they're going to work the same way. But you don't want to code that 3 times, and It just sounds like exhausting. So what you can do is you can there's other ways to go about this. You could use polymorphism, inheritance, stuff like that. You can use interfaces, but you can also use generics for this. And you can also use generics with other things. Generics aren't like a replacement for inheritance. They actually work really well with inheritance, which I'll show up here in a little bit. You can kind of combine them to do really wild things. But so say that idea, right? So what you can do is you can do public class, say inventory section, and then you would do t where t, and this is where we have to say, well, what are items considered like in the engine? I did it again. I always put this colon. Where t is by the way just like the standard terminology. Usually you would do t, or if you have multiple, you do t1, t2, t3, and so on. T is just sort of standard nomenclature or whatever. It's not required. Once you name this like it'll take well now it'll take that. But t is just standard, just stands for type. Um, or T is class. Let's say it's a class, right? Or I guess that would be a struct, right? Structs are kind of weird to work with though, but let's say it's a struct. And I want to double check, but I'm pretty sure. Um, a new can it can't be used as a struct. Does a struct just assume it has new already then? Yeah, okay, that's what I was thinking. Because structs, every struct, no matter what, not all classes have a parameterless constructor, but all structs do inherently. That's just a quirk how structs work. So I was like, it'd be weird to also have to add the new constraints. I was like, oh, okay, it just does it automatically. So struct. So struct inherently means you can do new. That's good to know. This is a quirk of structs. So we have that. So let's say, we have our helmets or our armor, we have our swords or shields, and they're all going to have just a struct of data because it's not really a class, it's more just a chunk of data. And structs are usually for that. So we have this, now we have that. This. So what we want is to basically use this is our inventory section. This is meant to be the interface for interacting with it. You would then do like, say we have an array of, or list, maybe use your list of whatever t is. And this is section contents. Contents equals new. This would be probably like public read only, so we don't want to change it to list. We can add and remove it. You can't like change it to a new list. Right. And then you'd have maybe functions in here that would be like add, move, so public void add. And then you do t item. And then you would like do section contents dot add. And then you go on and do like equipped, remove, whatever. And obviously we're tying to other game systems, but that would be the idea. And then you could go, say you have like three structs in here, so public struct, oops, not string struct, and say, oh god damn it, say this is swords. It has like int damage. It has different variables and maybe like a string name. And then we have, on this one, it's a whole different type, so it's a float now. And it's, block percent or something. This is shields. And then you have one more for armor, which is going to have even different, where it's like, I don't know, defense. So you have all these different structs, and they would obviously have a bunch of other different stuff on them. They have different like variables, different types. These are all kind of similar, but that's the idea. And then you would be able to do, you know, trying to figure out, this is a class. We're in here. This is another class. We're in a class in a class. Should I figure out where I am? So we have this class. So what we can do then is we can now up top do private inventory section, and we can input swords. So we can make one for swords. Don't really need that. No. Let's should have new. Actually, I think it just does that automatically because that's how structs work. So I think it automatically runs to constructor. Does it? I gotta name it sword. Then you can go. Just let me see. Does it? Will it get mad at me? Nah, well, it takes it. I think it might be redundant, but I don't know. And then you can do the same for a shield and armor. And then you obviously just change this out to shields, and this one to armor or whatever. And then any function we have in this, we can be ran from either of these, but it'll affect those different things. So we can run private void sample test. No, or some new test. We can do sword inventory dot section contents. You see, as a section contents, they'll all have that, right? Shield inventory dot section contents. It's an error because I'm not doing anything with it, but armor has the same, right? And you can also run sword inventory or any inventory to armor inventory dot. Then you can also add to the list. Add. Yeah, I think I was like, what's add? Oh, that's right. It's a function I made. New sword. Sword. Probably should have just named it sword. Sword. Actually, just make a constructor real quick for this just to show. Uh, public swords. There's an easier way to write these, but damage this dot damage this damage this dot name. There you go. And now we can just add this up here, and we add a say 5 and um, and that should take it. Why are you mad? Because it's armor. Just like carrying my own thing. That's right. So, sword. There you go. Yeah, and so you'd be able to, and you'd be able to do the same thing if you were to make an armor. You just have to add in an armor, and this way it's more flexible. You can basically make infinitely. Say all of a sudden, like, oh, we also want to add bows to the game or whatever. And then all of a sudden it's like, oh, I can just make a new struct and then just Control C, Control V. I can just do like this. Oh god, where's it? Yeah. Do bows. Name, and then damage. And then, you just do. There you go. Ideally, right, you would obviously have like these types themselves have some sort of structure, some sort of inherited structure and interfaces, and there'd be other stuff to these, but that would work really well. That would sort of combine those different flexibilities and scalabilities together. But this is a really scalable system, and I think that that's the main boon of generics in general is they're very scalable, and they're also very flexible and scalable. So yeah, so that's kind of how that's like a potential use case for classes. And then for functions, I kind of went over it earlier, but it's the array thing. It's where you can resize an array of just anything. I'll keep this around. I'll just kind of type it up real quick one more time. You just do public void brings let's do resize array. Let's make it a little better this time. Let's do obviously t t yeah, it remembers, and then let's do int. Let's do increase size. I was like, I could do size delta and like make it smaller too if it's below 0. But no, that's too much for this. Increase amount. Just do a null check if array. It's a good habit to get into is doing null checks if array. It's null because arrays are nullable. We do array equals. We get 0, and then we can just run over an arm. Not arm. Oh, so this is a one line in saving. Big over in 380. Basically what it is it's a if statement. So if you have an if statement, then you only have one line of code. You don't need to actually do the brackets like this. This is like you can just put it after it, and it'll just kind of indent it, and that's fine. If you need to do 2 lines of code, though, you need the brackets. Like this won't work. This is outside the if statement. It's only for one. It's really specific. It's just it's handy. But this is the same as this. It's just shorthand. Um, so yeah, so we have the array. Now what we can do is we can do t array. What am I doing? T new array probably better equals length plus increase amount. Oh, increase amount. Then we do for. I might want to do this a little bit differently. Oops. Int the lazy one. There you go. Int I equals. I'm gonna do new array, and then we're gonna need to do like an if statement set here to see if which one we're currently reading from. If we're reading from or creating new content. So if I is less than yes stat, this is where we create new content. So we do new array I equals yep, and then otherwise we do new array I equals default. I think was what I did the other time. Default. And I think there actually is a thing for default. I'm kind of wondering what that does. Because you can do it normally. This constraint revolves the ambiguity. We need to specify a constraint type parameter. Really weird specific thing, isn't it? It's like when you do an internal protected thing or something. Some higher level nonsense. What does this do? It's never a good sign when you go to the documentation and the thing's so obscure you're getting links to like design meetings. That's never a good sign. But they had to like debate on like if this was too asinine to do. It probably does something that's helpful, but I don't know what. It is an arrow to use encouragement over in. It's just too dense for me to parse. This allows it allows annotations for type parameters. It's whatever this means. I don't know what that even. What is an annotation for a type parameter? Oh, this is like some like rabbit hole of weird stuff. Oh, it's like new stuff too. It's like, or how new is this? How old is? Yeah, this is pretty new. I think they do sometimes update this and add new constraints. That's not unheard of. I think. I remember hearing Enum was new, but I think it was just the class. I don't know. So yeah, the language is always being updated, right? It's not a set in stone thing. Like in like 5 years, this language is gonna be. Actually, I don't know how quickly it updates, but it's gonna be different in like 5, 10 years. It's always moving and getting better. Or just different, I guess. Anyway, so then you can, you probably want to return it. Actually, no, because you're writing to it. Because it's a reference type, so you don't need to return it. You're just going to write to it. So array equals new array. There you go. Same thing. So, you can input literally anything into this and it'll work. You can input private void array test. You have to write things in functions. Okay, resize array new to create the array inside this. Come lazy. Let's do int. I can do ints. There's no constraints, so you can do literally anything. Uh, what's the most like? Trying to think of like the weirdest thing I can do. Can I do like graphics? Or wait, that's the wrong thing. 9. Let's do graphics dot. I was hoping it would give me something like it'd be an inheritance thing. I'm trying to find a weird chain of inheritance. uh, texture, text. Hmm. Uh, oh, here we go. Alignment options dot. You do alignment options. Here you go. Yeah, I guess I need them. Yeah, like it's a light green of enum. So you can do anything like with this. You can make it that bigger. You can make an array of um. What are we in right now? Generic use case example. Make a let's make like an ungodly amount of those. There you go. I'm pretty sure that's not a number that can actually. Let's make that like a reasonable number. That's still way too many. There you go. Yeah, so it works with literally anything. That's the fun of it. It basically turns C sharp into a sort of like softly typed language for a second. Um, yeah, so that's sort of some use case examples. The next thing I want to go over, we've done this, we've done this, and how long has this been? 40, Jesus. Final thing is just some other ways and some more like complex ways you can use generics. This is mostly review, I think. I think I went over most of this. Where did these namespaces get? This one, they just appear. I don't know where they come from. I'm scared. I think that's this one I do need though. Apparently I needed that one. Oh yeah, it was. Oh, because the alignment. Okay. Um, so I'm trying to remember which one I want to go over first. Okay. This one. So here once again, we have unconstrained generic classes. So we have, one with just one variable, no constraints. Then you have two, and you can kind of like get names and stuff. And then you have, what's this? You have three, and you can name them anything. Right? This is the point of showing this. Again, the type names is just kind of how I demoed these because there's no constraints. And then the other one is constrained things for classes. You can constrain. This one's an enum, so you can do stuff like enum get values. You can do stuff related to this because they're the same. There's this one. This one's to a class, so you can set it to null because classes can be. I think everything. I think classes are nullable. Everything are nullable. Everything that's a class is nullable, and everything that's nullable I think is also a class. I don't think there's anything that's non-nullable. That's not a class. I'm pretty sure. Array is a class. I think it has to be a class. I'm not even. At the very least, all classes are nullable. um, and then finally, uh, this is an example of using. This is actually a cool thing. I kind of accidentally learned you can do this, like, kind of today. When I was like, oh wait, why does it? I was trying to figure out why enum worked. And I was like, oh, because it's a class. Wait, class. And I realized like, wait, are enums all inheritance? And I kind of figured out like, oh, it's a thing. So this is something I kind of came into accidentally like today, just by the systemic nature of coding. But it's really cool. This is kind of a showing with actually no, it wasn't inheritance. So how this works is we have this example parent class, and then we have two children that inherit from it, and they each have so you have your parent function of just a debug that logs just the word parent, and then we have these overridden functions, a virtual one, so it can be overridden by the children, which means you can run it from them. And if you like just know it's from like if you just know oh this child is from this, so if you can do example parent, you can run functions on the child um, if only like even if you only know that it's a child of this class because this is here and it sounds weird if you don't know what I mean. It's kind of like interfaces, and it's just kind of how inheritance is, but it's really powerful. It's made even better with generics. So I'll show you in a second what you can do with that. And then there's finally let's see what else is there. Enum, I think this is the test enum I used. Just A, B, C, D, E, F, G. And then there's also a little section here on generic functions. I'll probably send off this file to you, to all of you. So this is just kind of how you format them. Two parameters, unconstrained. I did not spell that right. Then this one is constrained to a struct, and this one is constrained to these. This shows kind of how you kind of chain them together. Then there's a demo up here that uses all of these generic stuff from these three. Generics demo, generics, which is a mono behavior that's actually in a scene, like it's actually over here. Let me just restart this bit around for a bit. Where we have, so this is just like the different ones. So this is 1, 2, 3, 4. Another thing to mention, these are actually overloaded or polymorphic or whatever. these are the same name class. You can actually do the same thing you can do with functions where you name them the same thing but use different parameters, but with generics. So these are four classes that are different classes that have the same name because they have different generic parameters. So I'd say it's kind of neat. You can do the same thing with classes. So we have these, which if you go to the bug unconstrained, it just kind of prints out some stuff. I don't think this one's particularly interesting. I've already kind of covered the idea. You can see it just prints out the types we put in. So in this case, we put in an int and then an int and a bool. So you see it prints out int, bool, string, I think. Huh? Oh no, I don't think we're not the first one. But basically it's printing out the types, just as a name. To prove that's kind of putting them in there. Then we have enum, constrained enum. Oh yeah, this is a test of nulling. The error is intentional. So we have this one, which is debug class generic. This is just to a class. So what it does is it makes a game object. It sets it into that. It prints out the game object, and then it sets that game object to null using the function actually on the generic class, which is set variable null, and then does it again. You see the error, which is intentional because it's setting it null. Next we have enum, which is just going to tell you the contents of the enum, or like the contents, how many values are in the enum, which is 7. That's just what enum.getValues.length will do. And we can do that because we have enum in the generic. Next, we have an inheritance, which I think is the most interesting one. So what this does, and you can see it's pretty simple. So we have these three classes up here. The first one is the parent, and then we have child 1, child 2. As if you look at the actual, where did I put them? If you look at the actual one, so the parent's parent function, they all have the function called parent function. Kind of confusing, but they all have this function. The parents one just prints out parent, then child 1 prints out child 1, child 2 prints out child 2. So you go up here, you can see, okay, we have this generic that has, it takes an example parent. So everything that this will always have to be either example parent or inherited from example parent. So if I just go in and C3, and I try to make this just like another class, like a game object, it's not going to take it. It's not going to like it because it's not going to inherit. It'll tell you, oh, you didn't inherit. Yeah, so it has to inherit from or be that class. So what this means is we will always have access to this function from this generic, right? So we're using this generic thing. And I know it's kind of confusing because of these dots. It's really just this class example and the example parents just because they're side subclasses, just so I could type this up without it getting mad at me. But yeah, so basically because we know it's always going to be from example parent, and because we know example parent has this function, and because we know all the children of example parent are going to have this function because it's going to be inherited to them, and because we can also override this function in the children, because of that whole system there and the systemic nature of all this, we can basically just call that function of the child through the generic. And what that means in effect is we'll see, first we're doing the parent, then we're doing the first child, the second child. If you look kind of up here at what they are, you're going to see that print out in that order. So parent, child 1, child 2. And that's kind of cool. It's a really powerful system. You can do a lot with it. It's really scalable, and obviously you can do a lot more than just like print out the name. But yeah. And the final one on here is generic functions, which I actually don't remember what I did with that one. Types are the same. Yeah, I think I just took some types. That one's not too complicated. Nothing too interesting there. It's just functions. Yeah, so I think it's just these two that actually run anything. So we just, we look at the types, we're like, oh, these are, so we can check if they're the same or they're different. Because we don't have any constraints here, we can't really do all that much. And that's basically it for generics. I mean, obviously there's some finer details, there's some very strange nonsense, like whatever the hell this is, but for the most part, that's a lot more about generics, and just how to use them over just like singleton. I think the general idea with them is to create things that are like scalable, that you can basically have a more vague. Once again, it's a generic way to do a thing, right? So like if you have a task that can be done in a lot of different contexts, it's a way to just do that without needing to care about the specifics of like, oh, it's an integer, you know. And arrays are a good example. Like resizing arrays is probably the perfect example of that idea because like you just need to change how much stuff's in an array. It doesn't matter what's in it. And that can go for a lot of things. But yeah, that's sort of more in depth on generics. Hope this is helpful.